27L, taxi to hold short.
DL456. 99 passengers, crew members, dead because airplane windows had the wrong shape. This is the story of how 3 disasters changed aircraft design forever, and why every plane you've ever flown on has oval windows instead of square ones, or triangular. Oval windows don't exist for looks or manufacturing convenience. They exist to prevent planes from ripping apart at 35,000 feet. We only learned this after the world's first commercial jet kept falling out of the sky.
Good afternoon, sir.
Britain introduced the de Havilland Comet in the early 1950s, and nothing else in commercial aviation came close. While competitors still relied on propeller planes, the Comet flew higher and faster than any aircraft that had ever carried passengers. May 2nd, 1952, the date when aircraft registration G-ALYP completed the world's first scheduled jet passenger flight. A triumph that put British engineering at the front of the aviation race. But here's the thing, within 2 years, that same aircraft would end up at the bottom of the Mediterranean Sea with everyone on board. The first warning came on May 2nd, 1953, exactly 1 year after that historic flight. Comet crashed near Calcutta, India, and all 43 people aboard died. Investigators pointed to severe thunderstorms as the cause, and this allowed the fleet to keep flying. January 10th, 1954, everything changed. That pioneering aircraft, GALYP, took off from Rome, bound for London with Captain Alan Gibson at the controls, one of BOAC's youngest pilots, 31 years old, over 6,500 flight hours, around 27,000 feet. Gibson started a routine radio call.
George Howe Jig from George Yoke Peter. Did you get my...
The transmission never finished. The aircraft had literally disintegrated over the Mediterranean near the island of Elba, and all 35 people on board died instantly. 10 of them were children. Among the passengers was Chester Wilmot, a BBC journalist known across Britain. BOAC immediately grounded all Comets. Engineers worked through 60 modifications and returned the aircraft to service on March 23rd. It lasted 16 days. April 8, 1954 brought the same horror when the aircraft disintegrated at 35,000 feet near Naples. 21 more lives ended in an instant. There was no second return to service. Authorities revoked every Comet certificate. Prime Minister Winston Churchill made the investigation a national priority, declaring the cost of solving the Comet mystery must be reckoned neither in money nor in manpower. Sir Arnold Hall, director of the Royal Aircraft Establishment at Farnborough, took command of what would become one of history's most exhaustive engineering investigations. Consider the obstacles. In 1954, there were no flight recorders. The wreckage was scattered across the Mediterranean floor, and investigators were starting from almost nothing. Admiral Louis Mountbatten coordinated an unprecedented underwater recovery. Royal Navy teams operated underwater cameras for the first time in aviation history. Within months, roughly 70% of the Elba wreckage had been recovered, and that's when the real detective work began. Examining the victims, they found skull fractures alongside ruptured lungs. The pressure drop had happened so fast that passengers' lungs had expanded until they burst. Finding out why required something no one had ever attempted. Engineers built a water tank 100 feet long, 20 feet wide, and 16 feet deep. Then filled it with 200,000 gallons. BOAC donated a complete Comet fuselage, which the team lowered into the tank with wings protruding through sealed walls. Water doesn't compress like air, so a failure would simply split the structure open instead of triggering an explosion. This way, the team could study exactly how the aircraft came apart. Testing continued around the clock. This pace simulated roughly 40 times more flights than real operations over the same period. June 24, 1954 delivered the answer. After 3,057 simulations, a muffled thud echoed through the laboratory. Geoffrey de Havilland, the company's founder, arrived to witness the draining of the tank himself. The failure had occurred at the corner of an emergency hatch opening, and when investigators returned to the Elba wreckage, they found what they called the unmistakable fingerprint of fatigue, a crack running from a rivet hole at the corner of a window opening. And here's the engineering detail that killed 99 people. Corners are dangerous because of how stress behaves in pressurized structures. Cutting any hole into a fuselage at 35,000 feet means stress won't distribute evenly. Edges become stress concentrators, and corners make this dramatically worse. A circular hole concentrates stress at about 3 times the surrounding level. Sharp corners push that concentration even higher, reaching 3 to 4 times what smooth, curved openings allow. Every climb pressurizes the cabin. Every descent releases that pressure. Each cycle stresses those corners, and after hundreds of flights, microcracks form at the points of highest stress. Each subsequent cycle extends those cracks until they reach critical length. And what happens next isn't a slow leak. The fuselage fails completely and instantly. The Elba aircraft had completed roughly 1,290 cycles. The Naples aircraft about 900. De Havilland's test fuselage survived 18,000, but earlier testing had accidentally strengthened it through strain hardening, a treatment production aircraft never received. The official report, published February 1st, 1955, reached a definitive conclusion. The cause of the accident at Elba was the structural failure of the pressure cabin brought about by fatigue. The inquiry cleared de Havilland, acknowledging they had been working at the very limit of scientific knowledge. Understanding of metal fatigue simply wasn't advanced enough yet. Aviation changed permanently. In 1956 came fail-safe design requirements, mandating structures capable of distributing loads so other components compensate when one part fails. That principle still governs aircraft design today. Today, all commercial aircraft have oval windows built with 3 layers of stretched acrylic. That tiny hole visible in airplane windows sits in the middle pane, balancing pressure so the strongest layer can bear the full load. The critical piece of wreckage showing that original fatigue crack is on display at the Science Museum in London. Visitors can examine the exact failure point that reshaped aviation. Oval windows carry more than engineering efficiency. They stand as a reminder. Some lessons demand the highest price, and 99 people paid it so millions more could fly safely.